more slowly. Hold on, let me fix this.
I think it's great. I think it's good. Can you hear me? Okay.
Hi, everyone. Welcome to Pi Ohio. The talk right now that you're going to hear is Anne Schoenenberger talking about learning how to learn Python.
Thank you, Rachel. My name is Anne Schoenenberger. This is my Twitter account. I'll be tweeting stuff related to it, so you don't have to write anything down unless you're using it as a learning technique. I am from Greater Cincinnati. I work I'm a digital librarian. And I decided 2015 was my year of Python. I was going to learn as much Python as possible. My background, most recently, I've been studying instructional design and online learning, so I'm going to bring that into it. And I hope to bring that all into the discussion. So the audience, how many of you are beginners? Yay, great. But I tried to make it relevant to anyone by putting in some of the learning theories. So I'm going to talk about the resources that you use to learn. But I'm also going to talk about the process of learning. So I divided those up into 3 areas. The tomato. That represents your daily practice, the things you can do regularly to learn. The planet is the idea of lining what you're learning with your end goal. So the things that you're learning are going to help you for whatever you want to do in the future. And finally, the gear is you need to get feedback, critiques, as Catherine said, and you need to self-regulate your learning. So you have to sort of drive the machine, so to speak. To give some weight, as a solo learner, you're outside of traditional education. Maybe you might be part of that, but I'm learning without any teachers or university. I'm just learning on my own, and I imagine you are too. It's an important skill to be able to do that. So it's great that you are, and you should feel good about it. But before we learn Python, we're going to learn how to learn. And there's people who are experts in this. These are 2 of them. Dr. Oakley wrote a book called A Mind for Numbers. It's a little misleading. It's more about learning in general in science and technical subjects. She also did a short PDF about how to do good study skills. If you don't have time for anything else, just look at that and you can get tips. I learned about them from a Coursera course called Learning How to Learn. And the things I'm going to talk about in regards to learning is from that course. It's free, it's open, it's only 4 weeks. It doesn't take that much time. I highly recommend it. So I'm going to give you a little teaser just to get you interested. The tomato. Why is there a tomato on the screen? They recommend using the Pomodoro Technique. Pomodoro is Italian for tomato. The Pomodoro Technique basically requires you to, for 25 minutes, you eliminate all distractions and you focus on doing something. So in our case, we would be coding. Maybe we're learning coding. So you don't do anything else for those 25 minutes. Then for 5 minutes, you take a break. And then sometimes you take a little bit longer break, and you keep doing that. What that does is helps you to learn. There's 2 modes that your brain go into. There's the focus mode and a diffuse mode. And both of those are necessary for you to learn.
I hate to do this to you. I'm going to interrupt your talk for a moment. I really apologize. I apologize to all of you. I especially apologize to the speaker here because this is disruptive as hell. I need your transmitter. Because this transmitter and Brandon's transmitter are on the same. You may speak now.
Hello?
All right.
Okay, we're back in business. So you have two modes. In doing this way of working, you'll actually help. It'll help you learn. So I try to do I call them tomatoes. I try to do 4 tomatoes a day. That's about 2 hours. And so you can sort of set that up for yourself. How many are you going to do? It also helps, the daily practice helps you learn because the idea is, it's called spaced learning. So if you learn a little bit frequently, it's much better than doing it all at once. That's going to help ingrain these concepts in your mind. So maybe you'll even get up to 8 hours, the amount of time maybe you'd be working. Yes? It is that 25 minutes of focused work. So if I say I do 4 tomatoes, I do, it's basically a half hour of focused work, so it's 2 total hours of. The next strategy you can use to learn is something you should also do for 8 hours. Well, it's something you should do for 8 hours. Does anybody have a guess at what it might be? Yes, that's right. To me, this is the best news, some of the best news I may have ever heard, because sleeping helps you learn. So you have an excuse to go to bed at night. It clears out your brain. It reinforces the things you've been concentrating on. It actually it restores the good and takes away the bad. And if you work on things before you go to bed, your brain will keep working on them. So you don't even have to do anything. You just sleep. And there's scientific basis for this. This isn't something made up. They've done research. So those are two things for your daily practice. Have a regular practice, have focused and diffuse modes, and get enough sleep and work on things before you go to bed. So here's the resources. I created a list, kentonlibrary.org.python. The beginning of the list is things, if you're just beginning and then continuing to learn, the beginning of the list is sort of the things I've seen the most recommended. So it's a good place to start. If you have any questions about this, come talk to me and I can tell you about what I've done. But generally you ask, what should I use to learn? But and the quick answer is probably a lot of these things. It's not just one thing, so you don't have to worry so much about that. I want you to instead think about the goal and making sure what you're doing aligns with that goal. Does anybody know what this is? Other than a representation of my understanding of Python right now, it is a picture of Pluto. The only picture of Pluto we had, or our concept of Pluto, 6 weeks ago, 2 months ago. It took 9 years for NASA to get a picture that's like this. So that's what, in 9 years, this is how well I'm going to know Python as compared to those blurry pixels. So how do you do this? How do you align those things? To this, we're going to go to the field of instructional design. This is what instructional designers do. They analyze subjects, and they break it apart, and they make it so that you know when you do this, you're going to learn, and you're going to be able to do the end result. So they take a subject, and they break it into different domains. They call them domains of knowledge. So it's the building blocks of knowledge. So you can think of the building blocks of Python. So there's declarative, which is facts and definitions. There's concepts, sort of an idea of what a concept is. There's procedures, so how to do things, step by step. Principles, sort of the relation between things. Both of those are, by the way, are represented in your brain as if-then statements. So that should sound familiar to you. If I encounter this, I do this. It's sort of just many, many, many of those in your brains, and then you know what to do. And cognitive strategies, that's sort of the learning how to learn, the metacognition, how to think and how to learn, and those tools to do it. I left out one of these domains, one of the building blocks, and I left out the one that programming and coding falls in. Does anybody have an idea? They did a survey of people in hiring people, And they ask them, what's the thing that you most want in an employee? Ability to make decisions and solve problems. So the domain that coding falls under is problem solving. When you're learning Python, you are learning how to solve problems. What is problem solving? What are you doing? What is your brain doing? So again, from this instructional design model from Smith and Reagan, you're taking previously learned principles, procedures, facts, and cognitive strategies. You're putting those all together in a unique way. You're combining them in a domain of content, which is coding or programming, Python, to solve previously unencountered things. So you're actually doing things you've never done before, which I think is exciting. So what is your brain doing, or how can you learn how to do that? It sounds very complicated. The first thing, and I've learned this already, and from people in my study group, break the problem into subproblems. So take something big and break it into pieces. Next, you're probably going to have to search for some new information. It's something you've never encountered before. You're going to select and combine all those you're going to stack your building blocks. Then you implement and you evaluate it. Did I do it right? If not, you're going to go through and you're going to iterate. So you can solve it badly and then keep going and you're going to get better. What are some strategies for solving problems? These are just a few. There's many, many of them. So doing that search, Stack Overflow, go on the internet, look for new information, talk to people. Also use learning aids. Learning aids are when you can't memorize something. In Python, Catherine was talking about how big it is. You can't memorize all that. So you need the documentation. So again, I've learned that from my study mates. You have your documentation with you. And then you can hypothesize and test. So that's doing your first approach and then try again and get better. Science also says that your strategies are better if they're specific to that domain of knowledge. So if you're programming, look for strategies specific to coding. And two of those that I've learned, I'm looking for more. If you know others, please tell me about them, is Cindy taught me this, pseudocode. So instead of writing it in code, you write it in sort of natural language and then you turn it into code. And then top-down design is another way of breaking down problems. Emergent design. I have to write that down. Somebody tweet that. And there's more. There's MicroStrat. There's many more of these. So when you're looking at instruction and you're evaluating what should I do, look for these things like this. Sequence problem set. It builds from simple to complex. It takes those building blocks and you start with those and then you get to the problem solving part. And then maybe you solve problems you haven't encountered before. So it builds and sequenced. Good instructors will do that. Good instruction does that. Anchored instruction. That means you do it based on something you're interested in or you know about already. So you sort of have a sort of an advantage in that. Problem-based, you take things that you want to fix. So it's built-in motivation. And then cognitive apprenticeships, which people who are experts actually think differently than beginners. So it's sometimes why it's hard for experts to explain things and why when you're listening to expert, it sounds like Peanuts characters or the adults in Peanuts characters. So when cognitive apprenticeship means you're getting inside the mind of the expert so you can ask them step by step and say out loud, how do you solve problems? So try to convince them or pay them or bribe them to sort of get out of their brain what they're actually doing. And I think the idea of pair programming is probably based in that idea. A little bit of the problem when you're a beginner with problem solving is you haven't built up those fundamental pieces of the things you need before you can solve problems. So for Python, the principle and example is syntax. So you have to get the syntax down before you can do anything with Python. Procedures, how to open a file, how to write different pieces, how to make a function, how to make a class. You have to know how to do all the steps. You need to know the terminology, the facts. What is a variable? What is a string? What is a dictionary? And then the cognitive strategies, visualization, and all the things that help you think new things and learn. If you don't want to think about any of that, it's too much to think about. You can just think about two things, practice and feedback. When you're developing skills, it's two things. So it's those tomatoes, your time on task, you're actually coding, and then you're getting feedback. Python gives you some, so you know when it doesn't work. But then you're going to have to go beyond that, and we'll get to that in a second. This is a book called Design for How People Learn. It's much more accessible than the other one. And if you're doing any instruction or teaching, I recommend looking at it. Another strategy is the idea of scaffolding. So what that means in general, if something is highly scaffolded or supplanted, it means that the instructor is doing all the work. If something is generative or has low scaffolding, you are doing all the work. So as a novice, you're going to be moving from that supplantive to the generative. And as a solo learner, you're generally going to be doing more generative work. So that's another thing to think about and sort of look for. So when you're learning, it hurts a little bit, but not too much. You don't want to overload your brain. An example, Code Academy is known for being highly scaffolded. It's very supplanted. It tells you step by step sort of what to do, and you don't do much on your own. Contrast that with the Python challenge, which doesn't tell you anything. It gives you a hint, but you don't even know what you're supposed to do, so you have to figure it out yourself. Okay, we're to our final. This represents you. You're our gear. What do the gears imply? Other gears. If you're a gear with no other gears, there's no point. So what you need to, when you're learning Python, you're learning how to problem solve. You're learning how to learn. But you need to learn how to work with people too, because that's part of the process. So there's like organizations that you can do to meet people, and ultimately you're going to be getting that feedback that you need on your code. So you're going to do code reviews. You're going to get those cognitive apprenticeships, and find people like you. We have Greg here from Blacks in Technology, a wonderful organization in Cincinnati. If you don't know about it, check it out. Look for your user groups on Meetup. Start them. If there's other people like you, find people like you and create study groups. Code Newbie is a good place for beginners. You can start code clubs online if it's hard for you to get and meet with people, if your schedule doesn't allow. There's an element of bravery in this activity. For some people, it's very hard. But you'll find today and tomorrow, and in general, for some reason, Python people are extremely nice and welcoming. So just be comfortable just not knowing things. You know other things. Just think about that. You don't know Python, you know a lot of other things. Maybe they're just not asking you about it. So the gear also is regulation. So that's sort of you're driving the machine. You're in charge. Catherine mentioned that as well. You have to be your own project manager. So you can use something like a personal learning plan. So you actually set up sort of a project management for your learning. And I'm sort of interested in the idea of agile learning. And it comes back to the idea that you want to learn how you want to work in the future. So if maybe you want to be a web developer, so try learning the way that you might do web development. And that is also a very valuable skill. You need to be able to employ. I think it's the third most important skill, is being able to do that. So putting everything together, you have your personal habits. Maybe you make a personal learning plan. You have a personal learning network. And there, I didn't talk about it, but there's they call it the personal learning environment. This is more the tools and the communication methods. So we use Slack in our study group, and another one we use Google Hangouts. So put all these things together, and instead of a university, you have this. Instead of a formal education, you're creating for yourself, and you're doing a better job because you're the boss, and you're leading it, you're generating it. I wanted to end by thanking Pi Ohio for having me as a new person speaking, having all of us making tracks for just beginners. They don't always do that. And I want to thank everybody in my study group. Hi. Cindy is here. She's been especially helpful, and Brian too, my family. And it really makes everything worth it, and it's the best part, I think. I did create some forms for you for Twitter. So I made a hashtag. This is the official Pi Ohio hashtag, if you don't know. And I'm going to be checking the Learning to Learn Python hashtag, and I'm going to be giving away to randomly. I may ask someone to write a randomization program to do this. I'm going to give away a copy of the book to somebody who tweets. So thank you. That's it.